Hi. So for question 4, we've been told a particle of mass 0.8 kilograms is held at rest on a rough plane. The plane is inclined at 30 degrees to the horizontal. The particle is released from rest and slides down a line of greatest slope of the plane. Okay, so we've been told some information with regards to how far the particle has moved, how long it took the particle to do this, and we've been asked to find its acceleration. So this should be enough of a clue to tell us that this is a Suvat question. Okay, so the first thing I'd like you to do is to write out the Suvat variables along the side of the page. Okay, S being displacement, U being initial velocity, V being final velocity, A for acceleration, and T for time. Okay, so we were told explicitly in the question the particle moves 2.7 meters, so we know its displacement. The particle was released from rest. Okay, rest here is a keyword, so we know that it was released at a velocity of 0 meters per second from rest. We have not been told the final velocity. We want to calculate the acceleration, and we've been told the time was 3 seconds. Okay, so now we just need to select an appropriate formula to use to calculate the acceleration. Okay, so you can pause the video and try and have a think of which formula we're going to use. Okay, welcome back to the video. Q layer 1. The formula we're going to be using is S equals ut plus a half at squared. Okay, because we know the displacement, we know the initial velocity, we know the time taken, and we want to calculate the acceleration. Okay, so we're looking for a formula that contains all of the variables that we know and the variable that we want to calculate. Okay, so I'm just going to write out this formula again here. And what I'm going to do is on the next line, I'm going to substitute each of the values in. So we know S is 2.7, U was 0, times by the time, which was 3, plus a half times A times by 3 squared. Okay, so I'm just subbing each of the values into the formula. Okay, if we compute each of these now, 0 times 3 is 0, 3 squared is 9, 9 times a half is 4.5, so we're just left with 4.5a on the right hand side. Okay, if we divide both sides by 4.5, you should get a to be 0.6 meters per second squared. Okay, so we can fill in the acceleration here. We know a is 0.6 meters per second squared. Okay, you can also write down the plane if you want, or down the slope. Okay, but the fact that the answer is positive is indicative of this anyway. Okay, I hope you followed that first explanation. Moving on to part B. So for part B, we've been asked to calculate the coefficient of friction, mu, between the particle and the plane. Okay, so the first thing I'd recommend you to do for this question, like in any maths question, it's no problem. Okay, so we know that there's acceleration involved, and we know the value of that acceleration is 0.6 meters per second squared. We also know the weight. The mass is 0.8 kilograms, so therefore the weight is 0.8 g newtons. Okay, we can now resolve the weight We know this angle in here is 30 degrees, and that can be proved. .8 g cos 30 newtons. Okay. The force that does not contain the angle is sine, so this force here is 0.8 G sine 30 newtons. We know that there's a normal reaction involved here because the particle is not falling through the plane, it's not falling through the slope, so there must be something pushing up against it, and that's a normal reaction from the slope. So we have R newtons acting perpendicular to the slope, and the slope is rough. Okay, so the word rough indicates that there's friction involved, and friction always opposes motion. Okay, so it always acts in the direction opposite to the direction of motion. So we have friction force acting back this way. Okay, Q layer 2. You should be familiar with this formula, and it said that the friction force is equal to the coefficient of friction mu times by the normal reaction R. Okay, so we know we have the friction force acting up here, and we know that's equal to mu R. Okay, so newtons as well, all forces are in newtons. Okay, so what we can start to do now is we can start to resolve our forces. Okay, so first thing we can do is resolve perpendicular to the slope. Okay, so I'm going to be resolving into the slope, taking this direction here into the slope as positive. So we have the component of the weight acting perpendicular to the slope, which is 0.8 cos 30 minus that normal reaction R is equal to 0. We can therefore say, by adding R on both sides, R is equal to 0.8 G cos 30. Now what we can do is we can resolve down the slope. We can resolve parallel to the slope, taking this direction as positive, okay? And I do get asked a lot by students, why are we resolving down the slope? Why are we not resolving up the slope? How do I know which direction to resolve? And it does not matter. The correct values will always come out in the wash. If you resolve up the slope, you just need to take into account the fact that the acceleration is acting downwards. So in that calculation, you have to make the acceleration negative, okay? Due to the fact that acceleration is a vector quantity and it has both magnitude and direction, okay? So, resolving parallel to the slope, we have 0.8 G sine 30, the component of the weight acting parallel to the slope, minus the friction force, and we know that that is equal to mu R, so we're going to minus mu R, and that's equal to ma, mass times acceleration. And we know the mass is 0.8 kilograms, and we know the acceleration is 0.6 meters per second squared. Okay, from the first part. Okay, so if we rearrange for mu R now, we add mu R on both sides, and we minus this term here on both sides. We can therefore say that mu R is equal to 0.8 G sine 30 minus 0.8 multiplied by 0.6. Okay, and I'd recommend you to keep everything in terms of sine and cos. Okay, because despite the fact that we can compute exact values for sine 30 and cos 30, we could get angles that are not as friendly, and that would be very messy. So I'd recommend you to leave everything in terms of G, sine and cos, okay? Rather than subbing in G is 9.8 and putting in all the values exactly, okay? So what we can do now is we can divide by R, because we're looking to calculate mu. We want to get mu by itself, so we're going to divide both sides of the equation by R. Minus, so the numerator remains unchanged, divided by R. And we know that R is just 0.8 G cos 30. Okay? And before I calculate mu, I just want to bring up another point. You might be wondering why back here I equated this equation to mass times acceleration, and I equated this one to 0. That's just due to the fact that perpendicular to the slope. Moving parallel to the slope. Okay, acceleration exists in this plane. There's no acceleration here, so the acceleration is 0. That's why it's 0, and I equated this one to mass times acceleration. Okay. So coming back to this calculation, I've just given you a few seconds with that explanation to put this into your calculator. So you should have done this by now, and you should get a value of 0.507 for mu. Okay. To 3 decimal places. And mu has no units. Okay, mu is simply the ratio between friction and reaction. Okay, so if we rearrange for mu in this formula, by dividing both sides by r, we get mu equals F over r. The units of F is newtons, the units of r is also newtons, so they cancel each other out, okay? So mu has no units.